Hello, welcome. I'm going to create a new C++ console application. I'll set the project name as base live and give a different solution name. In case I'll call it application. And this is because we are going to create multiple projects as the series progresses. This is our empty project created in Visual Studio. I'm going to add a folder that is going to contain the scripts that we are going to write within this project. To add a folder, we first need to click on this button. I'll right click on the project and add a new folder which I'm going to name source. We also need to configure some properties for this project. So I'll right click on the project and go into the properties. First, we would like to tell Visual Studio to use the C++ 17 compiler. We also need to set these output and intermediate directories to these paths. What this one means is we are creating a new folder within our solution folder, which we are calling bin. And within the bin folder, we are creating a folder for the current platform. And within the current platform folder, we are also creating a folder for the configuration that we are running on. We repeat the same thing for the intermediate directory. Just that within the bin folder, we will create a new folder, which we are going to call intermediate. And this is necessary because we are going to create multiple projects. And since we are going to create multiple projects, it will be ideal for all our build files to be in the same location. We can click on this little arrow and click on edit, check whether our directories has been set correctly. And in my case, it has been set correctly. And hence I'll click on apply for the changes to be saved and click on OK. Before we write some code, let's discuss how we intend to store our metrics data. In C++, there are two memory types, a static memory known as stack and a dynamic memory known as heap. Data allocated on the stack is deleted immediately the data goes out of scope. In fact, it is ideal to allocate data on the heap since data used in programs may reach excessive size. However, allocating data on the heap brings extra work to the programmer because it is now the duty of the programmer to clean up all data allocated on the heap when the data is no longer needed. If the data is not properly cleaned, it leads to a popular problem with C++ applications known as memory leaks. This can greatly affect the performance of our application, and so we will also learn how to properly clean data allocated on the heap. Arrays created with this syntax are allocated on the stack. So here I'm allocating space to store 10 doubles on the stack. To allocate a similar array on the heap, I have to follow this syntax. Note the new keyword and the need to explicitly tell the compiler to create space to store 10 doubles. In fact, what is returned is not the array itself, but a pointer to the first element of the array. A pointer is just a memory address where a variable or an object is located. This means we also need to always know the size of the array to be able to access all the elements. Like we have seen so far, we are going to create 2- and 3-dimensional matrices. However, we are going to store the data with a single-dimensional array. Even though we could use multiple-dimensional arrays, they will not be optimal. That means we also need to arrange our data in such a way that it is easily accessible in memory. So for example, consider this 2x2 matrix. We will store the data in this form. That is, the elements of the first row followed by the second and so on. In this way, given a row and a column index, we can access an element by applying this equation here. We have a similar situation in the case of 3 dimensions, because a 3-dimensional matrix is just a stack of multiple 2-dimensional matrices. In terms of arrangement in the array, we still follow the first row first, then the second row. The extra thing we do is we store the first submatrix first, followed by the second submatrix. And hence, we can also access the elements of the matrices given the right indexes by applying this equation. And that is, following these conventions would help in designing a clean and an optimized framework. Back in Visual Studio, I have added a new file to our project. I've named the file main.cpp, and this file is going to hold the entry point of our application. In the file which I've opened here, I'm importing the IRISstream library. The IRISstream library is going to help us to print messages on the console. I've also implemented a function of an int return type, which I've named as main. This function is going to serve as the entry point of our application. Basically, that is where the C++ compiler is going to start the execution of our program from. Because of this, for every C++ console application, the int main function needs to be implemented. To check whether everything is working properly, let's display a message on the console. I'm going to display welcome to Spectral Educate on the console, and to do this, I need to call the cout function in the IOStream library. Because the IOStream library is part of the C++ standard library, I need to utilize the namespace standard, which has been shortened as std. I will build and run this project by hitting Ctrl and F5. And as you can see, we have our message displayed on the console, which means everything is working properly. We can go straight and start writing our matrix class. I'll right click on our project and add a new class, which I'm going to call matrix. Visual Studio created two files, that is matrix.cpp and matrix.h files, outside our source folder. So first, let's select these two files and drag them into our source folder. C++ uses two file extensions, that is a .cpp and a .h file, usually referred to as header files. The header files usually contains definition of variables and functions, whilst the .cpp file contains the implementation of the functions that we will define in the header file. So let's open our header file and create three variables to hold the dimensions of our matrix. We are going to create variables of type unsigned integer, and that is because we will not like to take negative values as a dimension of a matrix. We will also create a double pointer, which is going to hold the address of the first element of our matrix data, which means that we are going to create matrix of type doubles, but you can create matrix of any data type that you want. The only thing you will need to replace the double pointer to a pointer of any data type that you would like to create matrix of. We also add a constructor. Constructors are special functions that has the same name as that of the class. A constructor is the first function called on a class object whenever it is created, which means that the constructor will be the right place to initialize our matrix dimensions and also the matrix data. We can have as many constructors as we want, so far as we keep the function arguments different. So here we are going to create three constructors for the time being. We are going to create a constructor that will initialize our three-dimensional matrix and also a constructor that will initialize our two-dimensional matrix. We also add an empty constructor so that we will not always have to initialize a matrix dimension whenever an instance of this class is created. There is also a special function which is known as a destructor. The destructor also has the same name as the class, just that the name is preceded by a tilde symbol. Unlike the constructor, the destructor is the last function called on a class object whenever the class object goes out of scope, which means that the destructor is the ideal place to deallocate the memory that we would have allocated on the heap. With all these functions created, we can select all the functions and hold Alt and Enter for Visual Studio to automatically create the function implementation in the matrix.cpp file. In the matrix.cpp file, we can see that all our functions have been implemented. You can start by setting the values that we will pass into the constructor to the variables that we created. Once we've set those values to the variables that we created, we can estimate the total length of our matrix data. And this, we will need the total length to be able to explicitly tell the compiler to create space to store doubles of that length. With the total length estimated, we can utilize the new keyword to allocate space to store doubles of that length. Once the space is allocated, we can fill the space with values of ones, and that we can utilize this function, which is also in a standard library, which I will need to add to our matrix.h file. We can also repeat the same thing for our two-dimensional matrix, just that in this case there's no third dimension, so we will need to delete the ntubes variable. And with this, we have initialized our matrix dimensions and set the values to ones. Let's create a function that will print our matrix onto the console. I'll create a function of a void return type. Whenever we create a class in C++, the variables and functions that we define are private by default. Private in the sense that we cannot access either the variables or the functions outside the class. And that is what we want for the matrix dimensions and the matrix data, because we wouldn't like to be able to manually adjust the matrix dimensions and also the matrix data outside the class. However, we will need to have access to the constructor in order to initialize our matrix dimensions, and hence we will need to make the constructors and destructors public. Now let's implement our print function. Before we print a matrix on the console, we will need to determine whether the matrix is a 2 or 3-dimensional matrix. It will be a 3-dimensional matrix if the ntubes variable is greater than 0. If that is the case, the ntube variables determine the number of submatrices that are present in the 3-dimensional matrix. And hence, to print it on the console, we will need to loop through all the submatrices and print them on the console. Whenever we print a submatrix, we are going to print a new line. To be able to print our matrix on the console from this class, we will need to include the iRestream library. So I will include the library in the matrix.h file. To print a submatrix onto the console, we will also need to select the individual rows that are present in the submatrix. To print the entire row on the console, we will need to select the individual elements, that is the column-wise elements, and hence we will loop through all the columns that is present in the row and select the elements. With the two row and column indexes, we can apply the equation that we saw before to estimate the index of the element in the current math data array. Once we have estimated the index, we will access the element at that particular index within our math data array and print it on the console. We will also print a space to separate individual elements. When it is not a three-dimensional matrix, then it is a two-dimensional matrix. And we can repeat a similar thing for the two-dimensional case. Here I'm going to copy the two inner loops and delete the terms of the equations that are relating to a three-dimensional matrix. And with this, we can print our matrix onto the console. Going back to our main.cpp file, I'm going to create two instances of our class that we just created. However, to be able to create instances of the class that we just created, we will need to include the matrix.h file into the main.cpp file. I will create an instance of a two-dimensional 3x3 matrix and name it mat1. I will also create an instance of a three-dimensional 2x2x2 matrix and name it mat2. I will go ahead and print the two matrices on the console. And there we have it. We have first our previous message printed, followed by our two-dimensional 3x3 matrix and also our three-dimensional 2x2x2 matrix. I think that is going to do it for this video. If you like this video, kindly give it a thumbs up. And if you haven't subscribed yet, kindly consider subscribing. You may also share this video with your colleagues to help promote the channel. With this, I thank you for your attention and see you in the next video. Bye bye.